Hi students. Let me first quickly summarize what we have done in our last lecture, right? And if you can see on the screen, right, uh, whenever we are talking about x along axis, x-axis, any motion, any movement there, then we can say vi minus vm is equal to minus v square by u square and vo minus vm, wherein vi is you know it, right? It's velocity of the image, velocity of the mirror, and v and u, you already know this is distance from object, and this distance from I'm sorry, vice versa. So it's distance from the image and distance from the object. And vo again is velocity of object and velocity of the mirror. So this formula we already derived in our previous lectures, right? If you are not well versed, just go through it again. Right now on the y-axis we have, we actually derived this, which was velocity of image is equal to minus v by u into v velocity of object. But remember one thing here, that in this is the case when we have considered or assumed that v and u are constant. It's just perpendicular movement to the principal axis. Okay, so that is why I've given or written y-axis. As I have written here, this equation 2 is valid only when v by u is constant. Okay. However, if this is, if is not constant, so if v is by u is not constant, then what we have to do is we have to apply this formula of magnification, which is h, height of the image by height of the object, is equal to minus v by u, right? We have to use this and we have to derive it further. So this is a quick brief summary of the formulas which we have derived and which we would be using a bit. Now okay, let me move it here. Yeah, this looks good. Okay. Now let's talk uh, you know let's talk about when object moves at an angle with the principal axis, right? So when object moves at some angle with the principal axis, the diagram would be something like this, right? So this is the object. It is moving at an angle of 37 degree, and what I have done is I have taken up a question so that I can illustrate this method properly. The question is, there is a concave mirror with focal length of 20 centimeter. As you know, focal length of concave mirror is always negative, so make sure that you write it or consider the right sign. Okay, now this object is moving like this. So the speed of the object in this direction, which is 37 degree to the principal axis, it is moving at 5 centimeter per second. This is the speed of this. Okay, very good. And what they have done is they have given distance from O to P, which is 30 centimeter, right? So distance from the object to the pole of the mirror is 30 centimeter, hence u is equal to 30 centimeter. But remember one thing, that let me point it out here. See, this is the direction of incident ray in the case of concave mirror. So everything considered in this direction would be considered positive. Okay, but when I talk about u, which is distance of object from pole, right, the direction, as I previously stated several times, would always be from the pole. So from the pole to object, so direction would be something like this, and this is totally opposite of this. Okay, and that is why it would be minus 30 centimeter u. F, I already stated, it is focal length minus 20 it's 20 centimeter here, but again it would be negative. Why? Because if I complete this sphere, focal length would be inside, okay, and the distance would be always measured from pole to the focus. So it would be the direction would be again this, which is opposite to the incident ray direction, and hence it is negative as well. So we can quickly calculate and find V is equal to UF U minus F using this formula, which is nothing but a quick easier form of 1 by F is equal to 1 by U plus 1 by V. So we can find this, which comes to minus 60 centimeter. Now look at this question. So what they are saying is this body is moving in this direction. Okay, so point to note that U and V will change, right? Now because so the first step of this question is this motion, which is in this direction, I will break it up into horizontal and vertical. Okay, now if I break it into vertical, it will become 5 sine 37, and if I move it to horizontal, it would be 5 cos 37. Now this actually comes equal to 5 cos 37 would be in this direction, which is 4, and 5 sine 37 would be in the vertical direction, which would come as 3. Now quickly putting this and considering only the x component stuff and using this formula which we have derived in our earlier lecture. So Vi would become what if I just substitute all the things? Vm in this case is 0 because the mirror is not moving at all, right? Just putting this formula, minus V square by U square, V is minus 60, right, which we found here, and substituting it here, we get minus 16 centimeter per second, right? Remember, this is the velocity of image in x direction. So if I have to make you feel and make you understand what actually means when the body is moving in this direction, image would move okay, so let me take a step back. If the object is moving in this direction and we put a concave mirror here, then after breaking the speed into horizontal and vertical, the vertical component of the image we will derive later, but the horizontal component of the image would be minus 16 centimeter per second. Now if it is minus 16, so basically it means the direction would be from pole to the image somewhere here. So 16 would come somewhere here. So basically the direction would be somewhere here. Okay, the direction would be here. So it would be minus 16. That is what I have denoted here by the arrow. Okay, now we have done it for horizontal. Now coming on to vertical. See, in the vertical, we have one option wherein we could have used, let me quickly go or remind you the earlier slide summarized points that Vi is equal to minus V by U V naught. We can use that, but in this case we cannot use that. The reason being, as I have stated here, V and U are changing. See, because the body is thrown in a slant fashion. So V and U are continuously changing. If it would have been thrown in this fashion, we would have used the formula. But in this case, we cannot use the direct formula which we have derived earlier of converting everything in terms of velocity. So what we will do is, we will go to the basic formula which we know of magnification. Hi by ho is equal to minus v by u. Okay, cross multiplying we get h1u minus v h naught. Now quickly, differentiating both the sides, we get this, as per the UV rule. First we will differentiate this, and this will keep this as it is, which we have done here, plus then we will differentiate this, keep this as it is, here what I have done. And similarly, we will first differentiate this, keep this as it is here, and then we will differentiate this and keep this as it is, which we have done here. So I've written it here. Now look at this. See, height of the image at this point. Remember, we are talking about the instant. Now at this instant, the height of the image is 0 because it is on the x-axis yet. Okay, so this is 0. Okay, so this whole becomes 0. Okay, now remember, if they would have said determine this after 3 seconds, then the whole scenario or the question would have been more complex. So they will not give you that way. They will just give you simplified question. So in this way, you can say this 0. So this whole terms become 0. Quickly coming on to this. Now here, see dhi by dt. What is dhi by dt? See, dhi by dt is velocity of the image, vi, correct? And vi, what we have done is, we have found from here, it is, okay, u dhi by dt. What is u? Let me first put u, it is minus 30. Dhi by dt is nothing but vi. Okay, very good. Now coming on the right hand side, here we are putting here dho by dt. So what is dho by dt? They have given as 3 centimeter per second, the velocity of the object in vertical direction. So this is 3. Okay, minus here ho into dv by dt, height of the object is again 0 because it is at this particular instant. When height of the image is also 0, height of the object is also 0. So this whole becomes 0. Substituting, I can find vi is equal to minus 6 centimeter per second. Okay. Now this is vi in vertical direction. This was in horizontal direction. So if we have to sum it together, that what is the velocity of the image, we have to club horizontal and vertical. This is I-axis, this is J-axis. So I can say minus 16I minus 6J. Okay, let me reiterate the whole question again. See, in this case they have given, or the object is going in this direction at a speed of 5 centimeter per second. Okay, so what we are doing is, we will break into horizontal, this is horizontal, and vertical component. So the first thing is, we will quickly find using the UV formula F. Okay, then what I will do is, I will use for horizontal this formula which we derived earlier. We'll just put the values and we will get to know for the horizontal component that velocity of image would be minus 16 centimeter per second. Now for vertical, We could have used the direct formula which we derived earlier, but we cannot use that because in that case, u and v were, were constant. But in this case, u and v both are changing because it is thrown in a slant fashion. So what we will do is we will not use the direct formula, but we will use the base formula, which is hi by ho is equal to minus v by u. Okay, and we will differentiate both sides as we have done. We put in the values and we get this minus 6 centimeter per second. Now, a very important thing here in this question is that hi is 0, because this is instantaneous. At this point, the height of the image is 0. Height of the object is also 0 at this instant. There is no height. See, it is on the principal axis itself. So this term and this term becomes 0. Rest of the terms, we just substitute the values and we get v1 is equal to minus 6 centimeter per second. Add them together. If we add this and this, we get the resultant velocity in I and j direction, which is minus 16 and minus 6 respectively. So the answer would be vi is equal to minus 16i minus 6j. Okay, very good. So with this, I'm taking a small pause. We will continue and do one more question before we move to the next theory lecture. Till then, thank you very much.